Solving a system using substitution. This is our fourth method that we're learning for solving a system. We learned to solve a system by graphing the two lines and finding the intersection point, by making tables for each equation and looking for the ordered pair that was in both tables. And then we learned how to solve a system using y1 equals y2, which was our first algebraic substitution method. An algebraic substitution method is when you find the solution by solving an equation. So this new method, substitution, is a second algebraic method. When we used y1 equals y2, we needed both equations to be written so that y was isolated on one side of the equal sign, or x. To use this method, we need just one of the equations to be in that format. So in this example in the toolkit, our second equation is written so that a single variable y is isolated. It doesn't need to be isolated in the other equation. If it were, we would just go ahead and use y1 equals y2. So since y is isolated here, but not here, I'm not going to set two equations equal to each other, but instead I'm going to use the fact that for the solution, the y's and the x's in both equations, but importantly here, the y's are the same, and therefore since this y and this y are the same, I am going to substitute, that's where we get the name, substitute this expression in for y over here. So at the solution, at the intersection point, the x and y, the ordered pair, are the same for both equations. Y is the same, so since y and y are the same, and y equals negative 2x plus 13 at the intersection point, I'm going to substitute that expression in here. That first step is the important step, the challenging step. Once you've done that, this method is great. So I'm not substituting anything in for x. I'm substituting this expression in for y. X plus 3 times negative 2x plus 13 equals negative 11. So if you see what I've done, I've taken this first equation and instead of that y here, I've substituted the variable y in for this whole expression. When you do this first step, you need to end up with an equation with only one variable. If I somehow substituted incorrectly and put this in for x, I would recognize that right away because I'd have an x and a y. And in order to have an equation that I can solve, I need to have only one variable. So here is my first step. Sometimes my first step will involve substituting an expression in for x, and then I'd have an equation with only a y. Now I need to solve this equation, which involves simplifying the left-hand side first. Distributive property is used a ton in this strategy. So minus 6x plus 39 equals negative 11. Combining like terms, negative 5x plus 39 equals negative 11. And now that I've simplified that left-hand side, I can solve using inverse operations. Go ahead and subtract 39, and I have negative 5x equals negative 50. Okay. Last inverse operation, I divide both sides by negative 5, and hopefully you have a little more room on your toolkit. That gives me the first half of my solution, x equals 10. So I'm going to go ahead and write that to start with so that I know, hey, I only have half of my solution. This is the solution to this equation, x equals 10, but my solution to the system is an x and a y ordered pair. So x is 10. I now need to plug that x back into this equation. I'm going to suggest this equation in order to find y. I could also use this equation to find y, but it would be more complicated. I'd have to use inverse operations. Using the one that is isolated for y is a lot easier. Okay, so y equals negative 2 times 10 plus 13, which is negative 20 plus 13, which is negative 7. So I found x. I plugged x back into one of my equations, and I evaluated, and I found y. So I now have, what color should I use? I now have my solution to the system. Usually we will stop here. On the homework you can stop here, but on a quiz we really suggest that you are checking your solution, at least mentally, and I'm going to go ahead and show that step here. Since I found y using this equation, I'm going to use the other equation to check my solution. So 10 plus 3 times negative 7, does that equal negative 11? Does 10 minus 21 equal negative 11? Does negative 11 equal negative 11? Yes, it does. And that shows me that this ordered pair 10, negative 7 is a solution to the first equation. I think that it's a solution to the second equation because that's how I found the y, but I'm going to go ahead and mentally check that. Negative 7 equals negative 2 times 10 plus 13. Negative 7 equals negative 20 plus 13. Yep, negative 7 equals negative 7. That is our fourth solution method, substitution.